I'm Noor, by the way. We'll go through that in a bit. Okay, I think I see myself. I don't know if it makes. Do you hear me? Okay, I think I see myself. I don't know if it makes. Oh, I see. Do you hear me? Okay, it was just delayed a bit. Hey guys, the stream is on now, so we should be fine. Just text in chat, so I see that you're here. Hello, Dominic. How are you? So what I'm gonna do now is I'm gonna share screens. I'm gonna go through the intro to Arduino that we're gonna do. I'm just waiting for if anyone else is a bit late. I know there's a slight delay on the YouTube stream, so they might just be joining. So just give them a bit of time so they can text with us here. If you're on YouTube, I'm not checking the chat there. I'm just checking on Zoom. So join the Zoom link. I'm pretty sure it'll be on Discord, and we'll start in about a minute. Okay. I don't see anyone in the waiting room, so we'll just get started. I'm gonna share screens. Let's see. I'll share my screen just because we'll be going between the other pages. All right, you guys can see my screen, text and chat. I'm trying to get the chat open on Zoom here. There it is. Okay, perfect. I'm gonna start the slideshow and then we'll talk about what we're doing today. Okay, so intro to Arduino with Noor Nasri, that's me. So I don't know, for those of you that don't know me, I directed MasseyHacks VIII, so I'm glad to see the event is still running. I'm at the University of Toronto now. I'm specializing in statistical machine learning and data mining. And then I'm just finishing my co-op term. So if any of you come to Toronto, you can let me know. I'm gonna get started with the intro to Arduino now. But before we start, I need you all to go to Tinkercad and make sure you have an account. I don't know if they provided you like a school account or what they did this year. I know we don't have the physical kits. I'm sorry about that. They usually try to get them out, but it's a little hard with like a remote or a hybrid setup. So we're just going to be doing all our work on Tinkercad. I know last year I had like Arduino with me at least to like show you how it looks. I don't have that because I'm in Toronto right now, so my kit's back in Windsor. But yeah, go to Tinkercad, make sure you have an account. I'll give you a few minutes. It'll look like, I don't know if I can, it'll just look, yeah, it'll just be like the dashboard here, and then we'll be making circuits. But just to get Tinkercad working, and then I think you can like do where is it in Zoom? I think there's like the emote you can do, like a hands up emote or something when you have it. Just give me a little, just trying to see if we have it here. Remote controls. It'll be fine. Just text and chat when you're good. I see like one person with their thumbs up. So I'll wait until that's like 10 or when enough people text and chat. And if you have a question, by the way, it's a little hard for me to keep track of like the emotes and the chat and whatever. So just unmute and let me know. If you have like a question that's not like urgent, you can put it in chat. I have it open, so I'll get to it. All right. So I'm going to talk about the table of contents now. So it should be okay if you're still working on Tinkercad. Just make sure you have an account there. You can sign up quickly. The circuits are free to make, I think. Never run into an issue there. Close that. Let's go back to the slideshow. So this is the Tinkercad. Make sure you got it working. Now let's talk about what we're going to be doing today. So it's a bit longer than last year. It's actually a lot longer. So if you were with me last year, you'll remember this stuff. I want to go through it again just because I want to make sure we're on track. So there'll be circuits, Arduino programming, digital. Like this is just the stuff to get you ready with the basics of Arduino. And then at some point, once you understand these few things, you're sort of going to get the hang of it, and you just want to play with more components. So what we're going to do is we're going to give you a lot of time to just play with it. So this hopefully we'll get through in an hour or something. I expect it to run into a little after the break because I don't know if we'll get through all of this in like an hour 15 or whatever we have. But we will take a break at about what was it? 2:30 or 3. It's on the schedule, I forget. But they'll stop me, take a break on Kahoot. and then we'll come back, finish whatever we didn't finish, and then we'll do some practice challenges where I walk you through them at the end. And then we'll get to like the last hour where I just make it open-ended, go play with it. I have some things you can try. And then at the end, you can show me what you have, or I can work through something with you guys. And then I'll just be there for questions. Okay? Any questions, let me know. I'm gonna get started now. Yeah? Okay. I'm taking silence as no questions. So first things first, circuits. I'm just moving the chat for a second so it doesn't get in my way of seeing. Okay, so circuits. I don't know how far you've covered this in science, but essentially all you need to know for hardware is you have electricity and it wants to go from the positive to the negative. Just wherever there's a lot of electricity, doesn't like to be there, it moves around. And you can think of it like a balloon, sort of, where when you have all the air in the balloon, so you get it ready, tie it up, you have all this air and it doesn't have anywhere to go, but it could go. So we call that like potential. So that's what voltage is. It's the electrical potential. So you can have like a battery here and it has all this electrical potential, but it needs a path to where it's less charged, right? And it has to go through some medium. Usually we use copper wires. Again, I don't have them to show you, but they're like, I don't know if you ever worked with jumper wires. Anything that can pass electricity, something's a little different. We like to use copper because it's great. And once you let out that balloon, once there's a path for the air to exit, it'll exit because like it's all condensed in the balloon, and then you let it out and it goes to the air. And so that's just all that path is. And we're going to talk about the different paths. So first, the only thing you really need to know is voltage versus current. Voltage is like just that electrical potential. So if this is like a 5-volt battery or whatever, we're working with 5 volt in the Arduino Uno. We'll get to that. That's why I said 5 volt. But whatever it is, it's going to go through the path. Now, the actual amount of electric charge going through that path, that's the amps. That's the current. We measure that in amps. And it's the net rate of flow of electric charge. You can just think of it as like the voltage is like the difference in the electrical potential, and the current is how much is actually going through a certain path at a given point. Now, these things you'll notice are on the path. Like if it has to go, if there's only one path from where it's positive to negative, and it goes through the resistor and the LED, it has to. So these are what we call loads. They're the things on the path that will slow it down because it has to go through them. So if it just goes through the LED, it's going to turn it on. Now, the reason we have resistors to slow it down to a certain point so that it doesn't go too fast and burn the LED. And as long as we have things like this, it'll create a closed circuit that does whatever we want. Closed circuit is just that it's closed, right? Like there's no openings. It's just there's a positive, the negative, there's connected. If you have an opening somewhere, like right here, if open circuit, it won't connect because there's no path. And sometimes this, you mess up, something's going wrong, there's an open circuit, and sometimes it's by design. So for example, you have a flashlight, and in a flashlight, it looks very similar to this. It's pretty simple because you just have like a battery, and then it's going through, you have some form of resistor or multiple LEDs, and then all you're really doing when you click that button is you're connecting. There's usually here or here, like a metal clip. And when you click the button, all it's doing is connecting it so that the path is connected. And so it becomes a closed circuit. And when you click it again, like when you hear the click, it's that it pushed again, so it undoes. And so now, it's an open circuit and it doesn't connect. The only thing you want to watch out for is a short circuit. So that's, for example, if you have nothing here. If there is nothing, no loads, like if you have an LED, it'll burn the LED if there's nothing there. But if you have nothing at all, well, there is nothing slowing down the electricity. And it's going to go from one end to the battery to the other end super fast. There's just nothing stopping it. And it's going to go pushing maximum speed. And that makes a lot of heat. So it's going to heat up your wires, heat up your battery, and things are going to start getting a little dangerous. I don't know how bad it'll be with 5 volts, but it's going to heat things up, and you don't like that. So that's what we call a short circuit. And we'll talk about that a bit more later. Is everyone okay with circuits? Balloon analogy, flashlight. What else did we say? Oh, the outlet, like that's just usually what you have. You see there's like the 2 holes and like the third is something else. All right. Again, any questions, let me know. I'm going to go on to the next slide. So this is just circuits. Resistors. Resistors are the things, like we said, like the extra loads that their entire purpose is to slow it down. Now, there's 2 things you really need to understand about resistors. This little Ohm's law thing, it's more for science class. You can use it to determine like how many amps are going through a certain place. We're not going to worry about that too much here. All you need to understand is that it's like slowing it down essentially. And by how much depends on how strong it is, and that's measured in ohms. Okay, I'm just moving the chat around so I can see it. Now, the way you can read the resistors, we're going to be doing it in Tinkercad, so you're not going to have to go through that. But usually there's like the resistors are tiny and there's the coloring stripes on them. And on these coloring stripes, you can say the first, second, so on. All you care about are the first two. After that, it becomes more about tolerance. Usually, that's how it works. And then it's like a digit and a multiplier, and that'll tell you the ohms. Again, you're not going to have to worry about that today because we're just doing it on Tinkercad. But when you start seeing it in person, which is when this stuff gets fun, you'll notice it's going like, oh, I have to find the 220. You have to find the ones that are like, look, these colors are these colors. And there's very common, like 10K and so on. Any questions about resistors? They're just in your circuit to slow it down so that it doesn't burn your light bulbs or whatever you have in there. All right. Series and parallel. So now we talked about circuits, but when you're wiring circuits, there's two ways. And when you're talking about a complex system, it's going to have a bunch of both. There is a parallel circuit and a series. So what you've been seeing usually, like it's a basic start, is a series. And this diagram is a bit weird because like the long end is here, so it's going this way. So it should be R1, R2, R3, but it doesn't matter. Google Images isn't great sometimes. The series circuit, the electricity is going through everything here, right? So these are wired in series because there's no, like it can't skip R2 or R3 or R1. It has to go all three. In a parallel circuit, you have the electricity. It goes through right here. You guys can see my mouse, right, where I'm pointing? I'm waiting for a response. Yeah, good. So it's going through, because it would be bad if you weren't seeing my mouse. I'm just like talking randomly. It's going through right here. It gets to this point and it says there's two paths I can take. And what it's going to do is it's going to take essentially both paths. But there's a bit of a trick here where it's going to be proportional to the resistance. Now you don't have to worry about that two ways. Or you don't have to worry about that too much. You just have to worry about if I have parallel, it's going to go through each of the paths separately. So these are separate paths. It can go here or here or here. So it's going to take all three with different amps. The voltage will still be the same because the voltage is just, the difference. So if this is 5 volts, this is 0. That's still the voltage, regardless of the path. But the amps, how much goes through, it depends on the resistance. So for example, if we had a short circuit right here, just nothing here, what do you think is going to happen? Unmute or text in chat. If I just had one wire here to connect the circuit before it reaches any of this, what do you think is going to happen? Take a guess, because we're waiting. Yeah, I mean, it will burn out. Essentially, like what we were talking about it before in a short circuit is because there's nothing stopping it, so it's just going to keep going fast and fast. In a parallel circuit, you'll notice that if you have one here that is a short circuit, like nothing on it, it won't really send any electricity to the other ones because this one is just so much, like let's say these have like 10K ohms or whatever resistance. This has no resistance, nothing at all to stop it. So proportionally, pretty much everything ends up going to this invisible circuit we have here. And so these just get no power, and all the power runs through here forever and ever and burns it out. In terms of using it in homes, you'll notice that there's design. So a power strip right here, it will be in series because you want to be able to turn it all off and all on. That's the thing with series, right? It's all connected in one. So if one of them is wrong, one of them is broken, one of them turns off, there's like a switch between an open and a closed circuit, which is, again, like the flashlight example here, they will all turn off because it's one circuit. Now this is a bit problematic in like homes because you don't want, if one light bulb stops working, you don't want it to affect everything. So then you have a parallel circuit in a lot of homes, like that's how it's organized. Inside of parallel, you can have series because you're spreading the power too thin if everything is parallel. And that's, if you had a Christmas lights, you'll notice there's like a stack. It will be organized almost like a grid where there's like a bunch of parallel, but then it's not just 1, 1, 1. It's like the parallel to rows. The rows are series. And that way you kind of, like if one row goes down, there's still all the other rows, but you don't want to spread the power too thin between the lights. Does that make sense? For our needs, we're going to be working with like a series. You could add like parallel here and here. I guess we'll be working with both, but like it's simpler to start with series, and then as you add more complicated things, it doesn't become viable anymore. Now, breadboard is what we're going to be working with. And the reason it's called breadboard is just that's it started. Whatever board they had for bread, they slapped it on, put some metal nails or whatever they had, and put copper around, batteries, so on. And then you had an electrical current. And so a breadboard is for you to be able to do that. And the way we have it is like, it's like a plastic board, and there's like copper between it, the things. And you can see the way this is a small breadboard, it's connected. You have these lines essentially, which is supposed to be for your positive and negative. These two are not connected. So what usually happens is you connect them so that you can have it on both sides. We'll see that in a bit. And then, so these are in series here. And then these lines are sort of parallel to each other. And so you have here, here, and then these are connected like this. And so when you want to make a circuit on this, you will connect, we'll talk about the Arduino, but you'll connect some battery to the positive, and it'll run to here or somewhere where it'll go through some resistor, LED, and then back to the negative where it's going to be grounded, right? And that'll connect to the negative side. So breadboard might not make much sense until you play with it, but that's just a place for you to play with your circuits. Now Arduinos, that's what we're going to be using for this, I guess, tutorial or whatever we're going to call it. It's essentially a mini computer. I mean, it really is, like it has like a microchip and so on, microcontroller. And you can just think of it as like a programmable circuit board. And so we're going to see what that means, because we're going to connect, almost use it as a battery at first, and then we're going to start using programming with it, and you'll see why it's useful. As you get more complicated, you'll notice there's a lot of different boards you can use, like Arduino Mini and Mega for all your needs. There's also, you start getting to something that you want, like a stronger computer, and you go to like a Pi or anything. But that's what we're going to be working on today. You'll see it in Tinkercad. And so we're going to start by just getting to practice now. And we're going to wire an LED using the Arduino Uno. So I want you to go to your Tinkercad, and I want you to follow along because I'll be waiting on you to get things done at some point. So open up your Tinkercad, make sure you have it working. If you don't, let me know so we wait for you. You can just private message me if you want. And then create new circuit is what we're going to be doing. So here is your like Tinkercad thing, circuits, create new circuit. And if you already know this stuff, like feel free to go a little ahead. I think the slides are shared with you. If not, I can share them here. It doesn't let you create a new circuit. I'm not sure what, is anyone else having this problem? Like if I go here, I'm not sure how your account works. I can just see all my circuits here. I don't know if there's like a limit, but do try to follow along. I don't really know the, like I don't really know much about Tinkercad beyond just setting up the circuits here. So try to get it working. I'll give you like a minute. And we're gonna just tinker this new one I made. Okay. So what we're gonna start with here is just gonna be like a basic circuit. So you don't really need to know too much to get this working. And I'm gonna just paste in the Arduino. Now we'll be using the thing with the breadboard, but for now I want to show you it working with just this. Well, not even, okay, let's start without even the breadboard, and then we'll just add components as we go. Let's just have an LED. And let's do what we did. So this is our thing. And the LED, you'll notice, has like a short leg and a long leg. That's like a cathode and an anode. And I don't want to get too hung up on the terminology, but just think of like, you see how this is going from here to here, from the positive to the negative? The positive is the anode, and it's going to go through it to exit through the cathode. That's just the way you want to set it up, so you don't do anything unintended. And we're going to recreate wherever we had the light bulb. Yeah, you see here, we had the current flow, just the battery, resistor, LED. So what we're going to do is we're going to have this, we're going to have a resistor. Now for the LEDs, you want it to be 220 ohms. Okay. And what we're going to do is we're just going to connect it to 5 volts. I'm going to go 5 volt to the resistor, out of the resistor to the anode, out of the cathode to ground. And we can just put ground here. And I'll just color these a bit. And what this means, right, you have through the anode. Just if you look here, it'll tell you which one's anode and which one's cathode. And this is like, there's no programming, nothing's happening. When I run the simulation, what's gonna happen, or hold on, I color these backwards. The coloring doesn't matter, it's just some conventions, like you have the power with red and the grounding with black. And then, you know, you can use something else if you want somewhere, doesn't really matter. Here is my Arduino Uno, and it's like a microcomputer, and what happens is through the 5 volts, it will always be on. So whatever's connected to 5 volts will always get 5 volts, and I'm just gonna make this path for it to go through a resistor to slow it down, through an LED, and out back to ground. You can put the resistor on either side. Like, it's not like as it gets there, it's more, well, it depends on some of the components, but for this, it doesn't matter. So I'm just gonna run this, and you'll see it turned on, just because of that, just a circuit. And what we wanna start using is do a breadboard and put some programming. So I'm gonna keep going. That's a great way to spell. So I'm gonna put a small breadboard, and after this example, we'll just start loading in a setup like this. But for now, what I'm gonna do is I'm gonna keep the circuit, and I'm just gonna go like here. You'll see how it's still connected. So what'll happen is 5 volts to this column right here, up through, and it'll go to right here. And you can see how it's connected. And you can put them anywhere. Like I'm just putting them randomly, like this, right? And what sometimes happens is you don't have this middle one. It'll be easier to just, like if we just had this here, you'll see like you're passing power to this right here. And what you want to do is you want to do the power. If it's always on, you want to put it here, just because it's like sort of convention. And then you can connect it. And it doesn't matter which one you connect it to because they're all connected. And you just connect it, path through the anode out the cathode, and then back to ground. And if you just want to ground it, you can just ground it here. Oh, God. And then take this and ground that. Does this make sense now that we put it on a breadboard? So we've combined what we know about circuits with a breadboard, and all that's left is to start programming. Okay? Does this make sense? Any questions? Let me know. Oh, I think I closed the chat, but no one's chatting there. All right. Can you guys make sure you have it on your Tinkercad? So this is we're playing with an Arduino Uno. We just set up a circuit with a breadboard. And we'll do like the little emojis again, or reactions. So just give me like the thumbs up reaction once you have this ready. And I'm just looking at the count. So once we get to like 15, we'll keep going. Maybe that's too high, but I just want to know that you're all following along because we're going to start programming at this point, and I want you to be with me. All right, we're still waiting on a lot of thumbs up. If you're having issues, like let me know. So text in chat what your issue is. If you're all having that one issue with the circuit, let me know now so we can start all debugging that. All good, all good. Let's see. Okay, I suppose we're good here. So this is pretty basic. It's just using a circuit that's always on. So 5 volts is always on. When I start the simulation, this is plugged in. When I stop it, it's plugged out, so the thing turns off. Okay, so far so good. Now we're gonna put some programming in. So we'll go back to here, and you'll notice we're on this point, Arduino Uno, and we're gonna program. And the reason I'm putting this slide is to show you this, which is the link you'll be using a lot. And essentially, this is like, you can Google your questions. If you're just looking for syntax, so if you're familiar with like Python instead of C++, you just want syntax, this is where I would go. It's going to tell you how to use these functions. Like if I go to digital read, which we'll be doing soon, it'll show you how it looks like. Now, the first thing I want us to do, and again, these slides should be shared with you. If they're not, I can just send them. They're probably on like the I don't know what they sent. It's like a PDF or a picture. The first thing I want to do is set up the printing. So if any of you are familiar with programming, and this tutorial isn't meant to be like too programming heavy, it's all just hardware, and you can expand on that. It's so that we can print, which is useful for debugging. Sorry, it's a little weird when you're fasting, so no water, and then you got to talk. what's it called? The printing is not too needed here. Like we're not going to do anything that needs it too much. As we're going through, we're going to have like smaller problems where we print and then instead of printing, we'll do something else. But it's important to know, and I'll tell you guys why as we do it. So to start programming, go here, code and text. Don't use blocks. It's kind of weird on here. I mean, you could, I guess. And what we want to do is we want to turn this on when we want. So instead of always giving it power, we're only going to give it power when we want to. So we're going to give it, instead of 5 volts, we're going to use one of these. Okay. Oh, I guess so. Sorry. I confused myself. I wanted to cover printing first just because we wanted to. So none of this matters. We're going to keep it on and we're going to cover printing. Sorry about that. And you can get rid of the starter code they have. And all you want to do is serial.begin. And this will tell it, I want to start being able to communicate with my computer. Now, this is just a bit weird sometimes. Can you guys still see the camera? Do I have it on? I don't see my own. Oh, there is video. I just don't see it, so I don't know how I look. The serial.begin, it's a little weird to see here because it's like it's all on Tinkercad. But imagine my wallet is your little nice Arduino. That's what the program is. So when it does serial.begin, it's happening on the Arduino, which you notice the USB here, like for power. That's usually going to be connected to like a battery or your laptop. And what it's going to tell it is your serial monitor, or it's going to read it. That'll be on your laptop or computer, and that'll be listening for this baud rate. So that's just what the 9600 means. And then to print, we're going to go serial.print line, and let's just say like hello. And the reason I'm putting it here is because I want it to happen more than once. I want it to happen once a second. So the way this works is setup happens at the start. So this is just, you don't really need to know about code. Just you have to put something here to happen at the beginning. And then after it's turned on, it'll just keep running this. When it's done, it's going to call it again. So whatever happens here keeps happening. And because you don't want it to go like infinitely fast, you're going to put some delay to slow it down. And this is in milliseconds. So when I run this, this has nothing in it. Like the power is just on all the time. But the serial monitor is printing hello once a second. And it's not too useful for today because you're just printing. But when you start wanting to debug problems, you're going to use this. And that's just, when you're not sure something's going wrong, you'll put press statements here, see what the values are. And as you get more advanced, you need to know this. And sort of as you get more advanced, you'll be able to do more things with the baud rate. Because essentially, like this lets you communicate with an external device in like a really simple method. So you can use that as you get more advanced. Is everyone okay with printing? Because we're going to move on to just more wiring, lights, and so on. Okay, so I'm going to keep this on, but what I want to do now is I want to turn this to turn on and off, not always on. And we can't do that with the 5 volts because that's always on. So what we're going to do instead is we're going to go to our next step, which is digital write. I'll just walk you through it, but essentially, you just have to use these two things. You have to use one of these pins here. You can see where it says digital. And don't worry about the squigglies yet, but the ones that are squiggly, like the PWM, those also have the ability to be analog. And we'll get, or like PWM, we'll get to that. For now, let's just move this, or not the ground, the power. Why is it not moving? Oh, it's because I'm in the simulation. So we're gonna move this, and I guess we can keep the thing always on down here. But what we want to do is we don't want to connect it to the light bulb. We want the light bulb to only be on when we want it to be on. So I'll just move this like down here so you can see that better. And we're going to connect it to like say 4. And we'll put that where that used to be. So you see, instead of the power being connected to the 5 volts, it'll be connected to 4, which is just a pin we can turn off and on. And we'll just go, with digital, it's always all the way on or all the way off. So that's 5 volts or nothing. And I'm going to color this in. And so when we turn it on, 5 volts through, out, back to ground. Make sense? And the way you code that up is you're going to say, let's just use a variable because we want to be able to change it easily. And we're going to say LED pin, because this is an LED we're turning on. LED pin is, what is it? 4. That's just the number here. And you don't have to worry about it too much. You could just, int means that this is going to be an integer. So just do that for initializing your variables. And then what you want to do is you want to pin it. So you're going to do LED pin. You're going to do pin mode. And again, this is all on the slides, so you'll be able to see it later. All you got to do is tell the program that this pin, like number 4, is going to be output. So I'm going to be sending electricity. I'm not expecting to read how much electricity I get through it. And we're going to take the LED pin, which is 4. You can just put 4 there, but we're using a variable to make it easy. And we're going to do high. And you could also just put, like, it's technically 1 and 0, but use high. It's easier to see. And then, sorry, it's because I'm fasting. I keep pin mode first. You got to do output. High is turning it on. So let's recap, because I lost myself there because my brain doesn't function too much without food. First, you got to pin it in setup. Then in the loop, or if you want to turn it on in setup, you could. You got to turn it on or off. You'll tell it how much power to go through. And then you got to do digital write, LED pin, high. So again, this is going to look the same as the thing. Digital write, the pin and the value. Pin mode happens first just to tell it it's output. Does that make sense, or did I lose someone with my confusion? All good? Perfect. I'm just seeing if I want to give you guys something to work on yet. Okay, we'll get there. So I'm just going to make this blink now. So you see the delay. If I want to make it blink, all I got to do is first it's on, then it's off, which is low. So pin it, then in the loop, turn it on, wait a second, off, wait a second. And it'll go back to the top, which is on, so on. And if I run this, you'll notice it's on, off. And you can change the delay. You can make that another variable. So what I want you to do is make sure you have this and expand. I want you to make it 2 LEDs. And I want you to make one on while the other is off, right? So we're here. I guess you can see it there as well. I thought I put a slide to tell you what to do, but yeah, just make a second LED. First, you can make them both turn on and off, but I want you to control it with 2 different pins, essentially. When one is on, the other is off, and then they alternate. So get that working, and we'll get back. We'll take it up in a few minutes. And then when you get it working, give like one of the hand up or thumbs up so I can see the. Yeah, sure. Oh, do you guys not have the access to it yet? I'll just share. Here, it's in chat now. And if you're ahead, again, you can see the challenges we'll do later. It's a bit more open-ended just because I want you to play with the different components with hardware. But yeah, get this working and then make it 2. So here's the code. If you have any questions, let me know. Make it 2 of them. And just because I want the cops to come after you, we'll make it like red and blue and then make it go fast so it looks like the cops. It's just because we're funny like that. Does it show my, I don't know how the stream looks. Does it show just the screen, or do you also see my face in the corner?
We can see your screen and your face, yeah.
All right, well, Does anyone have it working yet? If you have it working, just do a little emote or message or something, so I know we can move along or give you more time. I see a few thumbs up. I'll give you guys another few minutes. And if you already have it working, you can see if you can figure out the rest on like the next step on your own. Just move down the slides. Because that is going to be the biggest thing with hardware. Like most of the times you're just checking like how to wire something or how to set something up with a syntax. So you're just doing a bunch of Googling and reading. And I want you guys to get used to that later on in the workshop we'll be doing.
In the meantime, I can send out the points code now, if that's okay.
Sure, just go for it. Yeah, so if anyone didn't catch that, he puts the point code. Any reason I'm getting that error, let's see your screenshot. Hopefully it's something I can help you with. Okay. Yeah, so something I should have mentioned is this is C++, so you need semicolons after each line that is a statement. And you know, we're really only going to work in statements here, like we'll just go over loops sometimes, but I only expect you to start hardware, no programming knowledge. So when you want to use a variable, which is just something that, you know, you can change at the top and it's going to show it throughout, just put what type it is. So we're going to be using integer, the number, semicolon. So the semicolon is what we're using. Yeah, no worries. And the serial monitor, if you do, you can clear it, just if it's annoying you. And then next time you run it, it'll go again. I mean, we're not writing, but I like to initialize the serial anyways in case you want to debug it. But yeah. So the thing you have to figure out with this problem is just if you want two different ones that are turning on and off at different points, how do you wire something like that? Which it's just really extrapolating what we know so far. Those of you that already got it, try to figure out, just keep going down the slides, see how far you can get. And then I think we're gonna take this up in about another minute. Okay, show of hands now, who's done? Give me like a thumbs up email. 1, 2, 3. Interesting. Okay, so I'm gonna walk you guys through it now because we're trying to get through a lot of examples, but I want you to keep working on it if you can. Just follow along with me. So how do we approach this? Well, the first thing you want to know is how can I turn one on and one off? Well, that means we need two different pins because the whole point is if something has to always be on, you can just connect it to the 5 volts here. Now this is getting a bit messy, so I'm gonna go to another one in case we want to refer back. And I'm gonna just search up the Arduino. Now I'm gonna start using this setup here just because it's a little neater, like to start with it. And this is just connected, like I said, the 5 volt, whatever's connected here is always on, and then connects back so you can use this one as well. And like, because this is separate from this, these are separate from this. You can see, like when you hover on one, it has like the green line to show what it's connected to. Okay. Okay. What we wanted to do is we wanted to turn on, I'm just trying to hide the chat, but I want to be able to see if you got new messages, but it does not keeping that on. It's okay. I'll just put that in the corner. It's not a big deal. Okay. So we want to turn on 2 LEDs. So let's just get that out of the way. We want to put 1 and 1. Let's make one blue, one red. Doesn't really matter. We'll just make this one blue. Is it not? Why this? Oh, I guess it's blue. It's usually they change the color when you do it. Okay, whatever. We'll get to why that is later. And what you want to do is you want to turn them both on. Now we know that regardless, like since they need to both turn on, the power is going to be like they're going to have 2 different paths because one is on, one is off separately, and they're both going to need a resistor. So I'll just move them a bit away for now, and we can move them closer if we want some effects. Okay, and so you could have it where it goes out the cathode and to the ground in both. And all that really matters now is right here, I want to connect power, and you could put the resistors after the LED. I'm just doing it this to keep it sort of simple, like, oh, you're getting slowed down and then you're going through the LED. These, again, we should make them 220, so it's not weird. Different ones will still work. Like if you make too much resistance, it'll just not be that light. If you don't put enough resistance, it'll burn. And actually, I think Tinkercad shows you like if you kill your components. So I made these 220, and all that's left is let's turn this on sometimes and turn this on sometimes, and they're just two different pins. Does that make sense? So I'm just gonna go 7 and 8. So I'm gonna turn these on. That's red, and this is like a green or something. I don't know if it'll change in the thing. Usually for me, it like changes a bit, or maybe I'm misremembering. Okay, let's go to the code now. So this is wired up. If anyone has questions, let me know. And all we're trying to say is turn this one on, this one off, so on. So the first thing we need to know is we need to have 2 variables. And again, you don't need to have variables, but it's nicer this way. Let's call it the blue pin, which is just going to be my left one. So whatever's connected here to make this path work, it's going to be 8, because this turning this on will go through here, and back down to ground. Blue pin is equal to what is it, 8, and red pin is going to be, what is this, 7. Okay, and I guess 7 and 8, I'll just put it like this so that it looks nice. Okay, now what you need to do is you need to pin them both to output, because you're pushing power through. Red pin, blue pin, and you're just going to write one of them high and the other low, because you want one on, one off. So turn this on, and the other one off. Then after a second, do the same thing, but do the opposite, right? Like that way, one on, one off. After a second, make the one that was on, turn it off, and the one that was off, turn it on. And then wait another second, and then rinse and repeat. Does that make sense? Oh, we did something. Oh, hi. On, off, yeah, and I don't know what it, oh, I'm an idiot. This is, you change it here. I don't know why I kept going there. I thought this would change it there as well. It might be bugged, but yeah. See, now it's blue, and if I turn this here, I'm guessing, no, it's always here. I guess it's because they have less colors, so they do it here. This is just the jumper wires, the wire color. Yeah, I haven't played with like hardware and Tinkercad in a while, so just refreshing my memory along with you guys. Okay, does this make sense? Any questions here on making them alternate? And I'm going, I want to make sure we're all following along. So if you have questions, let me know, because we have a lot of time in this year. So I'm going to make a variable for how long I want the delay to be. That way we can, make it change only one place, and it'll change how it looks. That way, now that I run it, I change the delay down to 300. Delay is probably not a good name, because that's the other built-in thing. So we're going to say something that's not delay. And you can see it's going faster. Everyone good so far? Thumbs up, so on. I need some responses so I know I'm not leaving you guys behind. Okay. Can I get another? Or if there's questions, let me know. So again, all we did so far is we wired up a basic Arduino. We put it on a breadboard, and now we're using two different digital writes. Now what we want to know is, okay, we got it. We can use LEDs. Let's go on to actually like getting things from it, not just writing. I guess we're gonna go analog first. I switched up the order last time. Okay, so what we're gonna do now is we're gonna say, instead of all the way on or all the way off, let's go in between. And that's what the PWM is doing. So we're saying, okay, let's go back to this one. Okay, and all we want to do is we want to start using the PWM, right? So instead of on 4, I'm going to switch it to like 3, which you can see the squiggly. And what I'm going to do here is it's the same exact thing. You're pinning it as output. I'm changing this to 3 because we moved it over to the PWM pin. So it's 3. So it pins 3 to output. And all that's different is instead of doing digital write, I'm going to do analog write. And that'll give me, instead of high and low, let's say I want it to be only 100. And then I can actually, like, you can still use it as digital. You can still do this. You can say digital write, because what digital write is essentially saying, it's write it as 0 volts or as 5 volts, like 0 or full. What we're saying here is write it as somewhere in between. And this is a number between 0 and 255. So, you know, like you can put 254 and it'll pretty much be on all the way, just a little bit less. And that's just how much electricity is happening to. And it just, some of the pins don't have that. So that's why the ones that do are the squiggly ones. Does that make sense? So now if I turn this on, you'll notice it's not as bright. And I will give you guys another time to work on this now, actually. So let's make sure we got, 0 to 255. You got to make sure, so on a PWM, same thing with pinning it, but then you just use analog write and you give it between. So this is also the same thing as if you just did analog write and you gave it 0. Are we good here? So I'm going to give you guys another thing to work on here now. Okay, so instead of 100 and 0, I want you guys to make it go all the way up and all the way down. Now, for those of you with programming knowledge, you can do this with a for loop. With those of you that don't, just use the thing we have so far. So for example, you can have an integer where it's like keeping track of the brightness. Whatever your integer is in the loop here, if you want to add it by 1, you can do plus plus. Or you can just do C is equal to C plus 1, like that's just changing it. If you want to make it go down, you can do C is equal to C minus 1. And if, I guess that there is a bit of programming there. I don't know if, I think I can expect you guys to understand a for loop because this is like MasseyHacks and you're probably a little further in. But for those of you that don't, it looks like this in C. You give it the variable. So like if I want to use variable I, you do for, you initialize the variable. This is just something that runs at the beginning. Then the thing that gets checked every time is like 255. And then the step, which is what happens every time, like we're going to do I plus plus. And what happens here will go 0, 1, 2, all the way to 255. And that'll be the variable in here. So if I did serial dot print line of I, and then I just delayed by 10, and I ran this, my serial monitor, you can see it's going up in a for loop. Yeah. So do you get that working? I want you to get the brightness all the way up and all the way down. Just one LED. Preferably don't use like this weird line. Just use the breadboard one that looks like this, but just one LED, and then we'll take it up, okay? And I'll keep this one so you can see the examples at the end. I'll keep this one the way it was. So this was just digital. But look at the slides for how to set up the analog. And then when we're taking it up, I'll put it in a new one. Yes, it's all the way up, all the way down. Okay, so let me know where you guys are. I want you analog write. Take the LED we have, take it all the way up, all the way down. And then give me the little emo or whatever it's called, the reaction when you're done. And if you're not following along, just please do, because we have a lot of time and I'm here to answer your questions, as opposed to opening a ticket or trying to Google it later. you're having trouble, let me know, or otherwise, let me know when you're done so we can take it up or walk you all through the solution. I think you'll need a bit more time, so I'll wait a bit. If you're done, that's great. You can keep looking ahead. The slides I've posted already. I'm just trying to mess around with this chat right now. With it, it's always in the way, so it's hard to see. So again, just giving you guys some time to make it go all the way up and all the way down using analog right. This is a setup for it, same thing as digital, but you can give it a number between 0 and 255. And if you guys need the setup for a for loop again, I can show you that. Okay, how are we doing? Can I get a thumbs up if you're done? And like a wave if you're having issues. Okay. All right, I'll take it up now. And towards the other end of this workshop, I'll just give you a lot more time to just work on whatever you want, ask me questions. For now, I want to make sure we know what way to approach it. So what we're going to do now is take it up. And I'm going to go over here again, because I'll share these with you at the end. I want you to have all the different examples. So let's do it again. Let's get used to setting up the Arduino board. And what I want to do now is I just want one that alternates brightness. Yeah. Okay. And unmute. Sometimes I'll miss the chat if you have issues. Okay, so now we have an LED, and the RGB is something we'll work on later. It's just essentially instead of one color, you choose the color. And where is this? We want it to always be on, but alternating brightness. So that's not really on. You're changing how much it's getting. So you don't want to connect it here. You want to connect it to what you're used to, the PWM. And we'll just connect it like over here because we want to pass a resistor. And just to show you, you can put a resistor at the end as well. You could even do this, like you could have it here and have a resistor go down here, like that. So as it exits the cathode, you have the 220 here, right? And you don't want to get too creative with it, but this is something you can do. I just want to show you the possibilities, you know. This is being weird. So we're going to put it on one that we can give it analog right on. I'm going to color this red. And let's code it. And all we're saying is we have, let's just call it LED pin is equal to 6, or you can call it PWM, whatever is easy for you to remember. And we're going to pin it as output again because we're giving it power. And then when we actually give it power, we're going to do analog right. And we're going to do the lead pin and how much. So 0 to 255. But we want to do that, incrementally. So we're going to use a for loop and stop me if I'm going too fast or too slow. So what we're doing here is just the normal for loop setup. So in the for loop, it'll start at 0, it'll go all the way to 255, and we're gonna give it that. And if it's too slow, sometimes you might want to make it like jump more. So instead of +1, you'll do it plus whatever. Since you're always passing it power, I like to just incrementally, like one at a time, just change the delay if you want. So that's the delay for it. Don't forget your semicolon. There's no semicolon on this line. It's just this isn't a statement. This is like a semicolon open. There's statements here, and those are separated. Okay. And then what you want to do is this is all the way up. You then want to take it all the way down, right? So you can actually do the same thing here. This is what runs first. This is what runs to check to see if the loop is going to happen. And this is just a condition. So I is smaller than. So while I is smaller than 255, we're going to do it. So instead here, we're going to do while it's bigger than 0. And instead of adding, we're going to subtract. We can use a different variable if it's weird. So we'll just do like x. You can also use the same and just, I'm not sure if C++ you have to reinitialize or like not have the int here to use the same variable. But yeah, you could have the LED pin here. You just assign it x now and you wait another 10. And let's just use another delay variable to remember, like, so we can change how fast it's going up and down. So 10 milliseconds between the brightness. And then we can get rid of this extra stuff. Does this make sense? So we pin it as output. It is on a PWM, so it has like a squiggly line, which means we can do analog write. And we're going to write from 0 to 255, wait on each one, then we're going to go backwards. And what did I forget? Void loop, I was not declared. Oh yeah. So you could, I mean, I can just use, like we used x here, so I'm using x. You could just use the same exact I, just that it's within this scope, so it'll get undeclared at the end. It's different from Python, and that Python you could use. And again, I just switched it to I here, so I got rid of the x. It just sometimes it's confusing using the same variable for 2 places, but it's fine. I believe in you guys. So now you can see it's turning all the way up, all the way down. Does anyone have questions? See, what I had in my notes is to give you guys, show you this, and then make it 2 again. But we just made the other one 2, so I thought it would be better to give you a chance to just make it brightness from the start. Now we're going to go on to the next thing. So this is how you use analog write. And now what we want to start looking at is using information, right? So we've been sending power, but now we want to receive power. Why is that useful? Well, there's a lot of components you can try. So what we're going to do now is a button. So digital read. So again, digital just all the way in because the button is either clicked or not clicked, like you're either pressing it down or you're not. And I'm going to show you guys how to use a button now. So you can see again, it's essentially the same thing where we have to turn it on. Like again, this is, or you have to remember a bit about the flashlight that I was on about, how there's like a connecting. You do the press and that'll put it in place. And this is really what's happening here. When you press it, you're connecting essentially the circle for the circuit. And when it's connected, there will be power coming out. And when there's power, you can send it to a digital pin and read that power. So when you read, so for example, if you're always supplying it 5 volts to this button, right? And then it goes through the button, out, and into your digital pin. We have a resistor here, and I'll talk about that in a bit. But when you click the button, what's really happening is you're connecting the circuit. So there's always 5 volts. You connect the circuit to your PWM, or it doesn't matter PWM, you just to a pin. It's also connected to ground here. So when you click it, it's connected to ground. The electricity is going to go pass through. Because there's electricity passing through, you're going to add this parallel one right here that can read the circuit, right? And using the resistor, like setting up a button, you can do it in a few ways. You actually could do it without like a resistor, and then instead of saying input, you can do like input resistor up, or I forget the term, but you don't have to worry about that until you get more advanced as to like the different ways to set this up. Just connect it the way I have it here. This should be fine for now. And so I'll set that up for you guys here on the side. Again, this will be shared at the end. I'll put it on like the last slide that you already have access to the slides. What is it called? Breadboard with the starter kit. Okay, so we have this, and we're going to turn on a button, and then we're going to use that button to use digital read, so we can read, is it being clicked or is it not being clicked? The wiring, again, I showed you guys earlier. I'm just going to put a button now. We're just going to do this. Like you could put it here. It's fine. I just like this because makes more sense. You can have extra stuff there. Okay, so the button, we're always going to give it power. Okay, so here's your power. We're going to go, and again, this is connected, so you can do like here or here. This looks kind of nice. And what you want to do is, since you want to control how much this is getting, you want to control the speed again, so resistance. And I think for the resistance, we're going to put 10K, so 10K ohms. But there's different setups for buttons, because all you're really reading is the power getting through, right? But sometimes, like, it's called, again, this is extra knowledge you don't need to know, but there's like a default state. Like sometimes by default it'll be on or it'll be off, or it'll just be like when you're clicking it, it'll know, but when you're not clicking it, it'll be like unstable, just based on your setup. We can talk about that towards the end. This is just the resistor here, so on. When you click it, this will connect. And all we need to know is, did we click it? So what you're doing here is over here, before it goes through the end of the resistor, we're gonna go and we're gonna say, let's read it somewhere. So I'm just gonna try to make it look nice. Let's go like here. Okay. And I'll just put this as like, I don't know, we'll make it stand out. This is what we're reading, okay? So this is just, again, you could do this like to the side and then back down. It's just that there's a resistor on its way down, so that that we can control the speed here. And then that way, we can just set it up as input instead of having to give it more stuff to do. So that's the button pin. We're gonna call this 13 because that's where it is. And just what we've been doing before, you're gonna pin it as input, because we're reading how much electricity is getting passed there. And what you want to do here is you want to see how much is happening, and you're gonna do int value, because it's only going to be like on or off. And you can see here I did like digital read, like this is the syntax. I would refer to this if you're ever confused, which is, I know, a link earlier in the thing. Digital read right here. So we'll just do like is held or whatever equal digital read, and then I'm going to show you guys how that looks. So digital read, and you just give it the pin number. So it just reads how much electricity is passing. And since it's digital, it's saying, is there any electricity? So it's attributing it as either 0 or, some electricity, which will just be written as 1. So for example, to show you guys that works, I'm also going to have the input serial.begin 9600. Again, that's just what the serial monitor is listening for, but you could change it around. Serial dot. You're going to print if it's held or not. And then I don't want it to print like eternally, so we're just going to delay, like we're going to see every second, is it held or is it not held? Okay. And now I'm just going to run it. And if I open up the code in the serial monitor, you'll see it is not being held. I'm going to click it, and you see it 1 now. I'm going to let go, 0, hold, 1. And that will just tell you if it's held or not. Now for a button, sometimes you want to see, did they just click it? Like if they let go, it's fine because they just clicked it. You have to change your code a bit to say, like, look for the change in state. And I can go through that. I think we have a different example for that, so I'll let you guys tinker with it a bit with the code. But does this make sense as to why a button works? More importantly, why digital read works? Yeah, give me a nice thumbs up if you understand. Raise your hand or unmute if you have questions. Again, we have enough time today, so even after the Kahoot, like we'll just keep finishing what we have. Okay, so I'm gonna keep going now. So this is how you use it, and I'm gonna see if I had. Okay, so I want you guys to combine what we know so far. Give you guys a bit of time before the Kahoot, and then we'll get back to the sort of the last step of analog read after you get back. But I want you guys to do now. Take this, and instead of printing, use it to turn on a light and turn it off, right? And then if you want like an extra step, make it where instead of like, first make it when it's held, the light's on. When it's not held, the light's off. After that, if you have it working quickly, make it where when you click the button, light's on. When you click it again, the light's off. Okay? Go for it. I'll give you guys 5 minutes. and then I'll show you how it is and send you to your Kahoots. Or it is, do I have another 30 minutes or is it 10 minutes? I forget what the schedule was. Scared of opening Discord here. We'll just keep going until the co-host tells me it's Kahoot time. And again, if you have it working quickly, just give me like a thumbs up. I'm looking at the participants chat. If you have questions, unmute, chat. Get it. You click the button, it's on, or you hold the button, it's on, and the next step is clicking. I'll give you guys 3 more minutes just to see how far you can get with tinkering with it. Okay, give me a thumbs up now if we're done. Or if you're ready for me to take it up. All right, I'll give you guys some more time to work on it. I think I said earlier 3 minutes, so you have 2 more minutes. Okay, I'm back. Hopefully you guys missed me. Just rushed around for a minute because waiting around. Give you guys another minute. And again, if you're done, get it to be like instead of while it's held, make it while it's clicked. And if you have that working, you can just read on the next part because we'll get to that after the Kahoot. Okay. I'm gonna take it up now, or I guess we can do a check first. Who's ready for me to take it up? Done. Thumbs up. Okay, so I'm gonna take it up now, and if you're not done, just follow along, or at least understand what I'm saying. What we're gonna do is we're gonna turn on. I don't know if I need a. I feel like we can just change this because this is just printing. We can keep the print if you guys want. Well, what we're gonna do now is we're gonna make it control light bulb. So where is our LED? Oh, it's there already. Okay, so we'll just put an LED somewhere here. And what we want to do, I'll just move this so it's a little easier to see. What we want to do is we want to read if this is on or off. So just moving this like to 4. And then what we want is we want this thing to always be grounded. And we want to give it power through a resistor only when we want. So that'll mean we have to do it on a digital one. Since we don't care if it's on or off, we'll just try to move this so that it doesn't get hard to see. So we'll use 12, okay? And we'll color this red. Stop me if there's any questions. All right, so now what we want to do is we want to change it where we already have a button. We're going to change, because we changed the button pin to 4, or 4, yeah. Grounded, I just mean that there is no volt. So if you remember what we talked about circuits at the start, there is a battery has like a positive and a negative, and electricity likes to get to the negatives from the positive. So if there's a circuit, it'll connect. Grounded just means it's a place that's negative, right? It's a 0 volt place. So what's going to happen is when we charge 5 volts here, if there is a path, like if I just do this, God forbid, I create a short circuit, right? Because it's going 5 volt, no resistance to the ground. I don't know how much damage 5 volt does, but yeah. So yeah, ground just means it's a place, it's access to the negative right here. And I'm just putting it on this line. So anything connected to this line is connected to that. All right. Let me know if that's still confusing. So now we're at pin 4 is for the button. We know if it's pressed, and what we want to know is when it's pressed, we're going to turn on pin 12, which is LED pin. And I'm going to pin input, output, and LED pin. All right. And what we do now is when it's held, so this is an if statement. Oh, I guess that's the problem if I didn't. You could also, like, since it's both digital, you could just write, like you could do, since we don't want to do too much programming, you could do digital write LED pin held. So this is if you don't want to do the so when you hold it, it checks every second. So when it checks, it'll turn it on. Oh, I think this is a little weak because we didn't, yeah. So it's, you see how what I said, if you put too much resistance, it'll be kind of weak because there's not as much electricity passing through. So we're gonna run it again. And when I hold it, it's on. When I let go, I mean, it'll turn off when it checks again. So if you want it to be more accurate, you can check more often. I'll just get rid of the print then so it doesn't spam it. I'll stop the simulation first. Get rid of the print so it doesn't spam it, and I'll check every 10 milliseconds. That way, when it's on, I hold, I let go. And it just takes some time because LEDs have, like, you know, heat. And I don't know if they use heat, but it takes a while for lights to turn off sometimes. Okay. I did ask you guys for this challenge, so I'll show you how it would be done. You want to see if it's being like held or not. So all you really would do is like the first time you see it let go, and there's a lot of ways to do this. Like you could do holding is equal to false. So we'll just do 0 now, so not get into it. And essentially, if it's held, right, what you want to do is you want to make sure that you're keeping track of that. Otherwise, I'm just trying to remember because I haven't done C++ in a while. So when you hold it, you remember that you've been holding it. And when you let go, if you've been holding it, and you can just do like else if here, but I'm just going to do this so we can see it easily. If you've been holding, then you just change, like you're no longer holding it, right? And you can turn this on or off, right? So this will keep track to know if it's being held or not. And right here, they just finished clicking it. So like they held it, they let go. You can do it all the way around where the first time they click it, right? So if they're not holding it and they click it, then you do it, right? And which might make more sense, but it depends how you want your button to work. So if you do here, you would just turn it on or off. You can have another variable for int on, and you can start it as off, and just always write whether or not it's on, but on ends up being 1 minus on. Weird variable name sometimes, but essentially what this is if it's 1, it'll be 0. If it's 0, it'll be 1. And if I write this, and it's again, this is not the greatest summation now that I think about it. There might be, but just some way where you keep track where the moment they let go or the moment they click for the first time, you do something. So I turn it on, I click again, turn it off. Okay? Any questions on this? I'm gonna send you guys to your break now. Just making sure any questions. So this is digital write and digital read. And then when we come back, we're gonna look at analog read. So we're kind of stretching it out a bit, but I want to be more thorough on this one. Let me know if you have any questions, any problems. Give me a thumbs up if you're ready to go on. Some thumbs up, please. I mean, the thumbs up is really checking if you're paying attention at this point, because I'm just asking if you're good to go. If you have questions, you can let me know in the chat. All right. Well, for those of you that are giving me a thumbs up, free to go. I mean, you're all free to go. Just the thing is happening on Discord, I believe. So just check the Kahoot there. I don't know if there's going to be, if I need to say anything here, I can check the. I don't know where it would be posted, to be honest. Somewhere here. I don't know. I haven't done the Zoom, so I mean the what's it called? The Kahoot. So you guys follow along wherever they tell you. Okay. We'll come back in 0.7. No, I guess we should. I don't know if they stream it or not. How does this work? Hold on. Let me text the organizers. I forget what we said for the Zoom or the Kahoot. But yeah, break time.